back to AP Review. This is 2005, Form B, BC Free Response 6. Consider the graph of the function f given by f of x equals 1 over x plus 2 for x values greater than 0. As shown in this figure, but also much better in the figure on the actual AP problem. Let R be the region bound by the graph of f, the x and y axes, and the vertical line x equals k, where k is greater than 0. Find the area of R in terms of k. All right, cool. So, part A, when we want to find an area under a curve, essentially it's top curve minus bottom curve, but if there is no bottom curve, it's just the x-axis, which is 0. So we're going to integrate 1 over x plus 2 with respect to x from 0 to k, right? So technically this is u sub and your u is x plus 2, but since your du and your dx are the same, if you can do this in your head, that's fine. You're going to get the natural log of the absolute value of x plus 2 evaluated from 0 to k. Right, which means that your area is going to be the natural log. You don't really need the absolute value at this point because what's going to happen is we know, so it's k plus 2, but since we know that k is greater than 0 because they told us that, we don't need the absolute value, minus the natural log of 2, and that's totally fine. You can leave your answer that way, and if you left in the absolute values, I don't think they're going to have a problem with it, but since they told you that k is greater than 0, you don't really have to. Part B. Find the volume of the solid generated when R is revolved about the x-axis, again in terms of k. So when we revolve about the x-axis, we're going to get a disk, right? A disk of radius top minus bottom, right? So when we go to do part B, the radius of this thing is the top curve, which is this thing, minus the bottom curve, which is 0. So I just get 1 over x plus 2, right? So my volume then, right, so the area of one disk is pi r squared, or pi times a 1 squared over an x plus 2 quantity squared, right? So the volume of this thing is going to be the integral from 0 to k with a pi in front of 1 over x plus 2 quantity squared, right? So this is u substitution again, right? So the thing to think about here is what you're really looking at is a u to the negative second du, right? Like if that helps you to picture it. So you're going to up the power by 1, which would be negative 1, and divide by the new power. So I'm going to get that this is a pi times a negative 1 over x plus 2 evaluated from 0 to k, right? Which is going to be it's up to you if you want to leave the pi out. I probably would. Negative 1 over k plus 2 minus a negative 1, or plus, you could say plus, and then you're plugging in 0, so plus 1/2, right? And that's probably how I'd leave my answer. If you want to distribute the pi, you can. I think the AP wrote it as a pi over 2 minus a pi over k plus 2, and that's also fine. There they distributed the pi and put it in the opposite order because they put the positive thing first, which is totally fine, but you don't have to. All right, part C. Let S be the graph of the unbounded region in the first quadrant, which this is what makes it a BC question for the record, because you're looking at something unbound, from k till infinity, as shown in the figure. Find all values of k such that the volume of the solid generated when S is revolved is equal to the volume in part B. So here's the thing, the only difference, this formula that you use in part B is 0 to k. You're finding the area of S the same way, but instead of doing 0 to k, you're going to do k to infinity, which is an improper integral, right? So I'm going to make note of this because this matters for later, so I'm just going to, since I'm going to erase some stuff, I'm going to write this at the top. So my answer to B, again, whichever way you want to put it, I'm going to put the pi at the front. I don't really care. So I'm going to write this one up here for my own benefit. You don't have to see it. I'm just recopying it so that I have it, right? So when I go to do C, right, C is going to be the exact same integral I wrote for B, except the bounds are going to be different. They're going to go from k to infinity. So to find S, right, so for part C, the volume for S, right, should be, now technically you're not allowed to use infinity as bounds, so I'm going to say the limit as B approaches infinity, and I'm going to do pi times the integral from k to B, right, of this 1 over x plus 2 quantity squared dx, right? But we already integrated this, right? We already know that this is going to integrate to a pi, well, I mean, put the pi where you will. It doesn't matter if you put the pi on the inside or the outside, but a pi times 1 over x, negative 1 over x plus 2, right? And I'm going from k to b, but again, it's the limit as b approaches infinity, right? So I want the volume of S to equal my answer from B, which we'll deal with in a second, but we're just going to copy that down. So if I plug these values in, what's going to happen is I'm going to get that this is the limit as B approaches infinity of a negative pi over B plus 2. We'll deal with that in a sec, right? Plus, now there's no need for the limit on the second term because the second term doesn't have a B, right? So plus a pi over k plus 2, right? Well, this is going to be a 0 as I approach infinity because I have a negative pi, which is a finite number, on top of an infinitely large thing. That's going to be a 0. So what's going to happen is that I get that this side is literally just this. And that is apparently equal to a pi times this negative 1 over k plus 2 plus 1/2. So what I need to clean up is this equation right here, right? And I'm going to do that sort of at the top because I don't need the graph anymore at this point, right? So what I'm going to clean up is I have a pi times a 1 over k plus 2 equals a pi times a negative 1 over k plus 2 plus 1/2. I'm going to go ahead and divide the pi's out and move the k plus 2's together, so I get a 2 over k plus 2 equals a 1/2, right? I'm going to cross multiply and get 4 equals k plus 2. So I'm pretty sure that I subtract the 2 over and get k equals 2, and that's the value of k such that they'll be equal. The end.